All right, welcome back to Data Maths Concepts. What we're looking at today is how do we solve a right angled triangle? So here on screen, what we're looking at is a right angled triangle named ABC, as you could see here. And we got some information. It says ABC, I'm reading right here, ABC is a right angled triangle. AC is 14, we have that right here. Angle C equal 90 degree, and we're referring to this angle right here, that corner. Size of angle B, 2. Size of angle A is 3 to 2. So there's a relationship between the angle at B here and the angle at A. All right. So the question wants us to work out the length of AB. So our intention is to find this side right there. Now, what we're going to have to do, though, is to ensure that we use the ratio between angle B to angle A, which is a 3 to 2. We're going to utilize that to help us to know the angles at A and B, and then solve the problem that we were asked to solve. So let's look at this. The total internal angle of any triangle, which means that the angle at A plus the angle at B plus the angle at C is 180 degrees. Now, because the angle at C is already 90, it means then that the sum of the angle at A plus the sum angle at B would be equal to 180 minus the 90, which is going to give us the 90. So we're going to share 90 between A and B, right, in the respective ratio that we got. So let's look at this. This is a total of 5 parts. So 3 to 2 is 5 parts. So what we want to do is to divide that 90 degrees into 5 equal pieces, and we'll definitely get 18. Now, angle B, so the angle at B will get 18 times 3, which is about 54 degrees. And the angle at A will get 18 times 2, which is 36 degrees. So if we want to put on our labeling here, angle B is 54 degrees and angle A is 36 degrees. Now, with that, we are now able to work out the length of AB. Now, let's look at the context. Depending on which one we want to use, we could use the 2 things to help us. But let us say, for argument's sake, I decided that I'm going to be using the angle at B to solve the problem. Matter of fact, I'm going to solve it 2 ways. So at angle B here, what we have is the opposite side. So angle B, focusing on that, which is 14, that's my opposite side. So I'm going to put OPP here. And then I have the hypotenuse to find, which is AB. So definitely, trig ratios will come in now, right? The opposite and the hypotenuse is sine. So the sine of 54 degrees is equal to 14, which is the opposite side, over the side that they asked me to find, which is AB. From here, if we transpose or move things around, we could use cross multiplication if we intend to. So basically then what we're looking at is AB times the sine of 54 degrees is equal to 1 times 14. Now, if we intend to find AB, we will divide both sides by the sine of 54 degrees. So we could finalize this to say AB is 14 divided by the sine of 54. So we'll go on our calculator and we plug that in. 14 divided by the sine of 54. Make sure that the calculator is in degree mode, please. And then to 3 significant figures. Let's look. We will be getting 17.30. but they did say to 3 significant figures. So we're talking about 17.3 centimeters. And that's our answer right there. So the length of AB is 17.3 centimeters. And that was just one way to approach that problem. Let us look at it from the other angle, 36 degrees. Our intention is still to find, AB. But remember that we are viewing it now from the angle 36. So let us take off some stuff here so that the diagram looks a little bit more clear for us to move on. All right. All right, so let's check this out. Now, using 36 to solve the problem. Now, 36, what is AB? AB is still the hypotenuse. It's across from the 90 degrees. So this is still our hypotenuse, which is in the situation to be solved. Now, if we look here, we're looking at 14, which is next door to 36. So it is the adjacent side to 36. So the trig ratio that uses the adjacent and the hypotenuse is the cosine. So the cosine of 36 degrees will equal to the adjacent side, which is 14, over the hypotenuse side, which is AB. Let us employ a quick cross multiplication here. AB times the sine of 36, and the cos of 36 should say, must equal to 1 times 14. Let's write this out. AB times the cos of 36 degrees is equal to 1 times 14. Dividing both sides by the cos of 36 to ensure that the AB is by itself. Then you could see that to find the value of AB, it's going to equal to 14 divided by the cos of 36 degrees. So let us make sure that our calculator is in degree mode. So 14 divided by the cos of 36. And we're getting the exact answer. We're getting that AB is equal to 17.30, but to 3 significant figures, it's 17.3 centimeters. So you could definitely see that the two approaches would have ended up having the same response. So as long as you're not making any error, here it is, 17.3 and 17.3. We approached it from 2 separate angles. Thank you for watching Daily Maths Concepts, and look out for more. See you next time.